Hello everyone. So today's session is about dark matter and dark energy. Earlier also I had recorded a session on dark matter, dark energy and quantum mechanics. That was a detailed session. There is an input to show dark matter and dark energy with some demonstration. So I'm trying to do that. I will try to create a simplified version today. It is going to be a more concise version and I would try to demonstrate it, both dark matter and dark energy, with some props. So to begin with, dark matter and dark energy both are major constituents of universe. They constitute 95% of mass energy density of universe. We think that everything is made up of atoms, whether it is life form like us, animals, objects, and the galaxies, stars, that everything is made up of atoms, which is true, but that just comprise 5% of mass energy density of universe. 95% mass energy density of universe is made up of dark matter and dark energy. So like around 68% is dark energy and like around 27% is dark matter and only 5% is normal matter. So like as I said, like dark energy is like around 68%, dark matter is like around 27% and normal matter is only around 5% of mass energy density of universe. So what is dark matter and what is dark energy? I'll take dark matter first. So dark matter, we don't know what it is. We are still in dark about it. It is basically invisible matter. It has no interaction with light. We cannot see it. We cannot see it, and that is why it is called dark matter. We only know about its existence because of certain observations being made in universe. But as I said, it has no interaction with light. It doesn't absorb light. It doesn't emit light. It doesn't reflect light. So we cannot basically see the dark matter. It is possible that millions of dark matter particles may be passing through us or passing through our homes right now, but we cannot see it. We cannot observe it. So how we know about the existence of dark matter, that something called dark matter exists, like something exists which is constituting the major mass of the universe. Like dark energy is energy, dark matter is matter. So normal matter and dark matter constitute the major mass of the universe. Entire mass of the universe is comprised of dark matter plus normal matter. And like around 84% of the mass of the universe is made up of dark matter and only 15 to 16% mass is made up of normal matter, which is like atoms. So dark matter, like we know about the existence of dark matter because of certain observations being made in universe. Like one of the observation is the galaxies which are formed, or the cluster of galaxies which are formed, or the superclusters of galaxies which are formed would not have been in existence if dark matter was not there. If we only account for normal matter, it was not possible for the clusters or superclusters of galaxies to have been formed. In the equation of mass, it is important to have the presence of dark matter. If we take off dark matter, the superclusters and clusters would not have been in picture. Another thing is, like the stars are orbiting in a galaxy. There are stars which are close to the galactic center, the center of the galaxy. There are stars which are there at the edge of the galaxy, which are also orbiting in the galaxy. We know Newton's famous formula of force, gravitational force, which is like G m1 m2 upon r square, which is the gravitational constant in mass of the one object, the mass of the other object, and the distance between the two objects, r square. It's basically r square. Yeah. So as the distance grows, the gravitational pull becomes weaker. The gravitational force becomes weaker. So the stars which are there at the edge of the galaxy, which are away from the galactic center, the velocity of those stars should have been much less compared to the stars which are orbiting close to the galactic center. There the velocity should be much higher compared to the stars which are orbiting near the edge of the galaxy. But that is not true. The stars which are orbiting near the edge of the galaxy are also orbiting very fast near the velocity of the stars which are orbiting near the galactic center. So why is that? It is only possible if our galaxy is immersed in a halo of some other kind of matter, which is helping in creating that kind of gravitational pull for the stars which are close to the edge of the galaxy, so that enough pull or enough gravitational force is there which can make the stars to orbit at that kind of velocity at the edge of the galaxy. So that is one of the observation which triggered the thought about some existence of some other matter which we cannot see, but we can feel the effect of it because it is creating that kind of gravitational pull. So the dark matter doesn't have any electromagnetic interaction, it doesn't interact with light, but it does have a gravitational pull. It does have that gravitational force. That was one of the observation which led to the hypothesis that some other kind of matter exists, which was named as dark matter. Then another thing is gravitational lensing. What is gravitational lensing? That is bending of light. Before coming to that, I will come to Einstein theory of relativity, general theory of relativity. So Newton gave us all the calculations about gravitational force, like between two bodies, between two cosmic objects or any two bodies. What is the gravitational pull? What is the formula? What are the calculations for it? But Newton was never able to explain what is the agent which is causing this force of gravitation, which is causing this force of attraction. In his famous book Principia also, Newton mentioned that I don't know what is the agent which is causing this force of attraction. But Newton was able to precisely give us all the calculations. Then came Einstein, another great scientist. And Einstein, with his imagination, with his thinking, came with a fantastic theory which is called general theory of relativity. And there Einstein said that gravity is basically geometry of space-time. So Einstein said, like, when there is any mass or energy concentration, it is going to curve the space, it is going to warp the space, it is going to create a curve in the space-time. Before that, the understanding was that space is just a stage on which all this cosmic drama is happening. But space itself is not having any kind of interaction with any of the cosmic object. It is just a stage on which all this movement of cosmic objects are happening. But then Einstein came, and as I said, he said that gravity is basically geometry of space-time. He said, when you put any mass or energy on the space, it is going to curve like a fabric, it is going to stretch like a fabric. So space is not something which is inert, it is interacting with the mass and energy which is present in the universe, and gravity is basically the geometry of space-time. So I'll just explain with a quick example, like if we just take normal matter, right? It was not enough to create clusters, right? There are some cosmic objects which are just sitting away from each other, and it was not possible for clusters or superclusters of galaxy to form if we don't take into account additional mass which is coming from dark matter, which is the invisible matter, hypothesized as invisible matter, which is present in the universe. So if you keep the dark matter, basically if you keep the dark matter, then basically the cluster can form or supercluster can form. So basically it is going to create a curve. It is going to create a curve in the space-time. I'm just adjusting this fabric to show the effect that it is going to curve the space-time, right? The space-time otherwise would have been straight. And for example, if you take our solar system, if sun would not have created that kind of dent, if sun would have not created that kind of dent or curve, and if there was an earth was there and it was traveling, then it would have just traveled in a straight line and would have gone in the space somewhere else, right? Where some other massive body attraction would have been there, and it would have forced to rotate around that massive object. What sun does, it basically creates a curvature of space-time, and that is basically leading to Earth and other planets moving around the sun in this curvature of space. So that is basically what Einstein said, that gravity is basically curvature of space-time. And as I said, the sun creates this curve and the planets are moving in this curve. And if we take away sun, then if the space which is curved will become straight, and the planets will just run away. They will just fly away till they find some other major massive cosmic object which is going to again take these planets in their influence, and the planets will start revolving around that massive cosmic object. So yeah, so coming to the other observation which is made about dark matter, basically even the light, when it travels in space, if because of some massive object the space is curved, then light is also going to travel this curved space-time, and that causes the bending of light. When we look from the telescopes, we'll see this bending of light happening. So if we just take into account the normal matter, it is not going to cause that much of bending of light which we see in universe. So when we put this dark matter into equation, this 27% of mass energy density into equation, then only we will see that much bending of light happening in the universe. So these observations basically led to this hypothesis that some other matter also exists in the universe, which has been called as dark matter, which leads to that much bending of light, which leads to formation of clusters and superclusters of galaxies, which leads to the stars moving at that kind of velocity away from the galactic center, edge of the universe also, edge of the galaxy also, they are moving at that high velocity. If we take away the dark matter from the equation, then these stars would be again flying away actually. They wouldn't be orbiting in the galaxy. They are orbiting in the galaxy because there is existing some other mass or some other force which is keeping them running at that kind of velocity, orbiting at that kind of velocity in the galactic center. So that is basically what is dark matter. We don't know right now what it is made up of. It is made up of light particles, heavy particles, combination of different particles, and there is also another theory about this matter, about this force, that this may be a force from a parallel universe. This is our universe. It is possible that there is another parallel universe which is causing this force actually, which is causing this force of attraction. Then there is another theory that this may be coming from other multiple dimensions. We are only aware of X, Y, Z and time dimension. The X, Y, Z dimension and the time dimension that we call as space-time. Space is X, Y, Z and time dimension, space-time dimension. But besides that, there is a possibility that other dimensions also exist. And it is not just a science fiction. Scientists are researching and finding out those other multiple dimensions and from where this force may be coming, this additional gravitational pull may be coming, which we are treating as dark matter today. So it can be another kind of matter which we don't know what it is made up of. It can be another force which is coming from parallel universe or from multiple dimensions, other dimensions. Now there are experiments being done about finding dark matter. There are experiments being done to detect dark matter. There is an experiment being done to create dark matter. So there are experiments like liquid xenon experiment in South Stanford laboratory in South Dakota. Then there is SNO lab in Canada. So there are multiple places where experiments are being carried out. I will not go into details about the experiments. I talked about those experiments in the other session of Mysteries of the Universe which I have recorded. So these experiments are carried out underground, like a couple of miles or 1 or 2 miles underground, so that most of the cosmic rays get filtered out, most of the particles get filtered out. So there is no noise actually. When we are doing the experiment, all these things are filtered out and we are just looking for dark matter interaction. But so far, the normal matter and the dark matter interaction we have not detected. That's why I said in the beginning that there may be millions of particles of dark matter passing through us right now, passing through the earth right now. But we have not been able to detect any kind of interaction so far. Then there is another experiment which has been done to create dark matter, which is basically in the Geneva, Switzerland. There is a Large Hadron Collider experiment, famous as LHC experiment, where there is a 27-kilometer long tunnel, and from both ends of the tunnel there are subatomic particles which are sent at tremendously high speed, near light speed, and they collide. There are collisions of protons happening, collisions of other subatomic particles happening, which will result in creation of other kind of particles. So they are trying to see if they can create the dark matter. See, the dark matter has definitely come from early part of universe. Otherwise the galaxies would not have formed. Like 500 million years after Big Bang, these galaxies start forming. So definitely dark matter is from early part of the universe, otherwise these galaxies, superclusters and all that would not have formed. So this tunnel is basically like a mini Big Bang machine. Big Bang is basically the exponential explosion which created the entire universe. So this is like a mini Big Bang machine which is called the Large Hadron Collider, and they are trying to do these kind of high energy collisions and trying to create these new particles. But so far no success. They have not been able to create anything like dark matter. These like millions of collisions are happening every second because it's happening at very high velocity. A lot of data is being collected, petabytes of data is being collected every day. A lot of analysis is being done. I think now quantum computers are also being deployed to do those analysis, but so far no success. We have not been able to create, we have not been able to detect any interaction of dark matter with normal matter. Then there's a LIGO lab where gravitational wave detector laboratory is there. So gravitational waves, like whenever any major collision happens, then there are going to be tremors, right? Any collision happens, major massive object collision happens, there are going to be tremors. So similarly in space, when major cosmic objects collide or major any activity happens in space-time, then there are ripples which are generated in the space also. As I said, like space can be stretched, there can be ripples on the space, right? Space can be folded, there can be curves in the space. So they are trying to detect these ripples of space-time. So we have been able to successfully detect ripples due to black hole collisions, due to neutron star collisions. So similarly, they are trying to detect collision between dark matter, normal matter, or dark matter, but nothing like that has been detected so far. So there are experiments being done, various experiments being done. They are also looking at ancient rocks and trying to find dark matter there. So many experiments are being done, but success has not been there so far. We have not been able to detect dark matter. Stephen Hawking, one of the, again, a brilliant mind, great scientist, he said that this dark matter could be composed of tiny black holes, primordial black holes. Primordials means from early part of the universe, because we are sure that this must be existing from early part of the universe. Otherwise, the galaxies and superclusters would not have formed. So experiment was being done for that also. Subaru telescope was being used at Hawaii, and Japanese team, Indian team and US team did experiment to detect these micro-lensing events actually. So Subaru telescope was there and it was looking at the Andromeda galaxy. It was looking at the Andromeda galaxy for the whole night. They were trying to look at the micro-lensing event. Lensing, as I said, is the bending of light. If a black hole is going to be there, it is going to bend the light significantly. Even if it's a tiny black hole, it is going to bend the light. So they were looking at they were looking at Andromeda galaxy and they were trying to see these lensing events, but they were not able to find any lensing events. Say there were so many tiny black holes which were there, they should have seen thousands and thousands of micro-lensing events. But that did not happen. So Hawking's theory of dark matter being composed of primordial black holes doesn't look to be true by whatever experiments have been done so far. So that is all about dark matter. So as I said, like we still don't know what it is, a lot of experiments being carried out, but still in dark about it. Now I'll come to dark energy. So dark energy is something which is like a repulsive gravity. See, gravity attracts everything towards it. Dark energy is something which is stretching the space-time. It is stretching the space-time, it is expanding the space-time, and the velocity is increasing and increasing actually, surprisingly. Like the dark matter, because the dark matter, a lot of structures are being formed, right? And because of this structure formation, the expansion of universe should actually slow down. But that is not happening. The universe is running away faster. It is expanding faster. The space is stretching. So I'll just show with a demonstration like what is happening. Like if you take a balloon, we have two dots on the balloon, right? Those are like galaxies which are close to each other. And like if I'm filling air in this balloon, the balloon is going to get expanded. Similarly, the space is getting stretching. Space is getting stretched. It is expanding and the galaxies are running away from each other. So the 3 dots which are very close to each other have now moved away, and as I'm going to blow more and more air, it is going to move further and further away actually. Right? So similarly here I know like I'm filling in the air, which is like the energy which is stretching this fabric of the balloon, and the dots are moving away. We don't know what is the energy, what is the dark energy which is stretching this space-time and taking these galaxies away from each other. So these galaxies are running away from each other at a speed of 70 kilometers per second if you move 3 million light years away. Like if we are here, if this is our galaxy, and if you look at 3 million light years away from our galaxy, that galaxy is running away from us at around 70 kilometers per second. Still a lot of experiments are being done to find out whether it is 70 or 68 or 72 or 74. I'm taking an average number of 70. And if you move another 3 million light years away, this galaxy A, if you move B, this is another 3 million light years away from this. And with respect to us, like it is 6 million light years away. So that is running away from us at 70 plus 70. That is like around 140 kilometer per second, and so on. Like if you make these jumps, 4,740, around 4,740 jumps will reach speed of light. So any galaxy which is away from that threshold will not be able to see, because the light is not going to reach us. It is running away from us more than speed of light relatively, so the light is not going to come from those galaxies. So if dark energy is going to continuously stretch this space-time, the galaxies are going to move away and away, and the time will come when all these galaxies must have crossed the threshold of light speed, and island galaxies would have formed actually. We will not be able to see the other galaxies. Universe will be a darker place. It will be a dark place, and gradually it can happen that even the galaxies, the cosmic objects which are present in the galaxies, will move away from each other. The solar system may be there, and then the solar system may also get stretched, and the planets may be there, and then the planets may also get stretched and disintegrate, which has been called as a big rip by the scientists. So that may happen billions and billions and billions years in the future, but that is a possibility if dark energy keeps on expanding the universe at this rate, right? If the dark energy gets diluted, then the dark matter is going to take over, because the dark matter is something which is helping in creating of the cosmic structure. It is compactifying things because it is forming clusters, it is forming lumps. So then it is possible that everything will start coming together, and there can be a big crunch, which is opposite to big rip. There can be a big crunch actually which can happen if the dark matter takes over and the dark energy gets very diluted. So the state of the universe today is because of the balance of dark matter and dark energy which is there today. And for dark energy also a lot of experiments are going on. Like in 2022, Euclid telescope is going to come into picture. European Space Agency is working on it with help from NASA. So they are going to do a lot of study on dark energy, and that is going to be operational by 2022. And then there is another Arizona, there's another additional attachment called DESI, which has come to the Malay telescope. Malay telescope was existing before, but they have a new attachment to it which is being called DESI, which is basically dark energy spectroscopy instrument. It has a robotic array. It has 5,000 fiber optic sensors, like 5,000 eyes which are looking into the universe, looking at 5,000 galaxies at the same time. It looks at 5,000 galaxies at the same time with these 5,000 eyes or 5,000 these fiber optic sensors for 20 minutes. Then it moves to another set of 5,000 galaxies after 20 minutes. So the goal is to look at 35 million galaxies in this way, collect a lot of data about dark energy, and try to find answers actually what it is exactly doing, what is the expansion rate and all that. So as I said, like in Pune, in Ayuka Lab Pune also there's a large synoptic survey telescope which is trying to find out a lot about dark energy and dark matter. So a lot of experiments are being done throughout the globe to find out more about it, and even like a lot of simulations are being done using artificial intelligence, like AI, artificial intelligence. Though we don't have a lot of progress in artificial general intelligence, like which can have the intelligence like a human being, but yeah, artificial narrow intelligence (ANI) is doing. There are significant leaps in ANI. ANI is able to beat the chess experts, the grandmasters of chess, Go, Jeopardy game. A lot of ocean exploration is being done using AI. And we have driverless cars also. We have humanoids also, which are trying to emote and talk like humans. So similarly, in field of space also, artificial intelligence is being used, and just hope that we are able to get more insights using this artificial intelligence, which can give us a lot of answers about dark matter and dark energy, we are able to make progress, or at least we'll be able to know that what we know is more incomplete than what we think. So I'll leave you with that, and yeah,